Building the right electrical system for a ground+3 floor house is, honestly, a serious task. It is not just about putting wires and switches together. The whole design must ensure everyone's safety and that all your appliances work without trouble. Calculating the electrical load is, really, the first step to a safe and reliable setup. If the load is too high for your system, wires may overheat, breakers may trip, and fires can start. If you guess too low, you could waste money on cables and meters that are far too large. Good load calculation also helps you plan for future needs and possible upgrades. This is why professionals always begin by calculating the load, especially in multi-story buildings like ground+3 homes. Homes today use more power than before. Air conditioners, water heaters, lifts, and pumps all draw lots of current. When you have several floors, the chances of overloading increase. A carefully planned load calculation ensures each part of the house gets the power it needs. This guide will show you step by step how to calculate the load for a ground+3 house using a 3-phase meter. We will also explain important concepts along the way, so even if you are not an electrician, you will learn why each step matters. The first step in load calculation is making a list of every electrical device in your building. Go through each floor, starting from the ground floor to the third. For each space, note every light, fan, plug point, and major appliance. This detailed list becomes the foundation of your load assessment. On the ground floor, you might have a living room, kitchen, and utility area. List items like ceiling lights, tube lights, refrigerator, microwave, water pump, and sockets for small appliances. Move to the first floor. Include items for bedrooms, bathrooms, hallway lights, air conditioners, and geysers. Repeat this process for the second and third floors. It is important not to overlook equipment used outside the building. For example, outdoor lights, a gate motor, or garden water pumps must also be included. If the building has a lift, make sure to note its power rating. Some ground+3 homes also have rooftop water tanks with electric pumps. By the end of this step, you should have a clear spreadsheet or notebook page listing every device, grouped by floor and room. Record the power rating in watts or kilowatts for each device. If you are unsure, check the label on the appliance or consult the manufacturer's website. Once you've listed every device, add up their power ratings. This total is called the connected load. It's the maximum power your building could use if everything runs at once. Add the wattage for all lights, sockets, fans, and appliances on each floor, then sum the subtotals. Don't forget big items like air conditioners or water heaters. They can really add up. The final number, in watts or kilowatts, is your building's connected load. Not all devices in a building run at once. That's why we use demand factors. Demand factors reduce the connected load to a realistic maximum demand. Codes provide tables for these factors. Multiply each group's load by its demand factor. Add the results for your building's true maximum demand. This saves on costs and prevents overloads. A 3-phase supply is honestly the best choice for a G+3 home because it can handle high loads efficiently. However, you must balance the load across all 3 phases. If one phase carries much more load than the others, you get voltage drops, overheating, and poor appliance performance. To balance the load, divide your circuits or floors so each phase carries about the same amount of current. One common method is to assign each floor to a different phase. For example, the ground floor circuits could be on phase 1, the first floor on phase 2, and the second floor on phase 3. The third floor's load can be split among phases as needed to equalize the total. Sometimes, it is better to balance by circuit type rather than by floor. For example, all air conditioners can be distributed across phases, not grouped on one. Large, single-phase loads like pumps should be connected so that no phase gets overloaded. You should regularly check your calculations as you assign loads. If you find one phase carrying too much, shift some circuits to another phase. An electrician can use a clamp meter to measure current in each phase during operation, ensuring balance. With the maximum demand known, you can now work out the size of the main service cable. First, convert the maximum demand, whether it's in watts or kilowatts, to current in amperes. For a three-phase system, the formula is current equals maximum demand divided by the square root of 3 times voltage times power factor. So, let's assume a standard voltage of 415 volts for three-phase supplies. The power factor for homes is usually 0.8. For example, if your demand is 12,000 watts, the current would be 12,000 divided by 1.732 times 415 times 0.8, which is about 21 amperes. Next, choose a cable size that can carry this current safely. It's important to add a safety margin, usually around 20 to 25%, to allow for future loads and to avoid overheating. You should refer to cable manufacturer tables for the correct size. Also, consider factors like cable length, method of installation, whether it's buried, in conduit or overhead, and the ambient temperature. If you have long cable runs, voltage drop may be a concern. Check that the cable you select keeps voltage drop within legal limits, which is usually below 3 to 5%. Always round up to the next standard cable size for extra safety. The final major component is the three-phase energy meter. The meter must match the maximum current your building will draw, as well as meet the standards of your local utility company. The utility will often specify meter types and approve your load calculations before installation. Choose a meter rated for your calculated maximum current, ideally with some margin. For example, if your maximum current is 25 amperes per phase, a 30 or 40 ampere meter is suitable. Make sure the meter is certified for residential use and supports features like tamper resistance and remote reading, if required. Some utilities require meters with built-in current transformers for higher loads, so check if your installation needs these. The meter should also be compatible with your distribution panel and circuit breakers. Installing the correct meter ensures accurate billing and compliance with safety standards. If you misjudge the meter rating, you may face tripped breakers, faulty readings, or even fines from the power company. Let us recap the steps for calculating the load and setting up your G+3 home's three-phase supply. First, make a detailed list of all devices and their ratings, floor by floor. Add up all wattages to find the total connected load. Next, apply demand factors to estimate the building's actual maximum demand. Use this value to guide your cable and meter choices. Balance loads across all three phases, either by floor or by major circuits, ensuring each phase carries a similar load. Calculate the current required for your main service cable using the three-phase formula. Choose a cable size with a safety margin, accounting for installation method and possible voltage drop. Finally, select a three-phase meter rated for your maximum current and meeting utility standards. Each step is important. Skipping any can lead to safety hazards or costly mistakes. Double-check your calculations at every stage and consult a licensed electrician before final installation. Correct electrical load calculation is not just about numbers. It keeps your home safe, efficient, and future-ready. By knowing your building's real needs, you avoid overloads, electrical fires, and surprise outages. Your system runs smoothly, appliances last longer, and your family is protected. A well-designed three-phase supply handles high loads with ease. Balanced phases mean fewer problems and lower maintenance. You also save on energy bills because your system works at peak efficiency. When you plan for growth or new appliances, your setup can handle the extra demand. Always follow local codes and consult professionals for final approval. Modern homes are complex, but with careful planning, you can enjoy all the comforts of technology, safely and reliably. Electrical load calculation is the first step to building a home you'll be proud of for years to come.